deck to start that. So once we have confirmation from the chat that the recording's going, I'll proceed.
I think we're up and running.
Excellent. So other orders of business before we jump into it. First, please mute your microphone to avoid having background noise. If you like to speak, you're welcome to raise your hand in the chat, and then we'll call on you to unmute yourself and speak up. In addition, you're welcome to use the chat box to ask questions directly. And then finally, if you do unmute and speak up with a comment or question, please state your name for the record so that we will know in the recording and in the minutes who was addressing the topic at hand. I'm quickly looking at the agenda, what we'll be covering in this meeting today. We'll start with the welcome and introductions. I know this is not everyone's first time together necessarily, but we still want to have a chance to make sure that everyone has a chance to introduce themselves, where they're coming from, and any new faces can learn who's here and introduce themselves as well. Then we'll quickly review the working group schedules coming up, just to make sure that everyone's aware of the upcoming meetings and the time we still have left in this initiative. Next, we'll get into the meat of the presentation, providing an overview of hydrogen infrastructure. This will be a opportunity to provide more details, information on the cost, location, regulations of hydrogen pipelines and hydrogen storage, and how they fit into a broader hydrogen ecosystem in Connecticut and elsewhere. And then finally, we'll discuss, we'll have an opportunity for Q&A discussion on the presentation, as well as some discussion of next steps. So a quick reminder of Strategen's role in this effort. The Strategen team will be handling meeting logistics, including scheduling and recording meeting minutes. We'll be coordinating with working group co-chairs to develop meeting agendas. These will be provided to participants a week before working group meetings. Strategy team will provide technical assistance, and it's expected that these working group meetings will meet on a monthly cadence. So this is the meeting for the month of October. Next one will be in November, and we'll get into more detail about that schedule in a little bit. But as a reminder, meeting recordings and meeting minutes will be made publicly available on Connecticut Community Bank's website. Feel free to reach out to myself if you have trouble accessing those details. All right. Now let's do a quick round of introductions. My colleague Nina can look through the participants in this chat and calling out one by one. Everyone will have an opportunity to share their name, their title, and the organization they represent in this meeting.
All right. I'll go ahead and just go first. Like Colin said, I'm Nina. I'm with Strategen, supporting as a senior analyst in the infrastructure work. Go ahead and go to Trent.
Hi, I'm Trent Moulter. I'm president and CEO of Skyr. And just so everybody knows, we make hydrogen separation and compression systems and also electrolysis systems.
Right. Okay. Lydia.
Hi, everybody. Lydia Rupert, research analyst with the Connecticut Department of Energy and Environmental Protection.
Liam.
Hi, Liam Daly, gas analyst over at Eversource. I'm sitting in for Nikki Bruno today.
Sam.
Sam Carter, at the Conservation Law Foundation in Connecticut.
Awesome. And then Samantha.
Hey there, Sam Danowski, she, her, the state director of Sierra Club's Connecticut chapter.
All right. Sarah.
Sarah Hari, Associate Director of Innovation and Senior Advisor to the President at the Connecticut Green Bank.
Tyler. We can go and move to June, maybe.
Sure. This is June Wooding from Eversource. I work on the business development for clean technologies, and I'm also here in lieu of Nikki Bruno.
And then Adolfo.
Hi, you can see me now. So Adolfo Rivera, Senior Director for Green Hydrogen at Avangrid.
And then I think Andrea, sorry.
Hi, no problem. I'm from the intersection of the South and Midwest, so I do go by Andrea. Nice to meet everyone. I'm with Toyota.
I think, and then Aaron.
Hey, good afternoon, everyone. Erin Childs, Director with Strategy and Consulting. Very excited to be helping to support coordination of these work groups.
Then if there's anyone I missed. Okay, I think that's it.
Excellent. Thanks, everyone. We'll continue moving through then. So quickly, we wanted to make sure that everyone had a chance to focus in on the working group meeting schedule for a second so that we're all on the same page in terms of upcoming events. This is the October infrastructure working group meeting. The sources and uses working group are also meeting this week tomorrow. The funding working group is meeting on Wednesday, and the policy and workforce development working group met last week. Now we're working on keeping everything on a monthly cadence. The next meeting of this working group will be on the 17th, which is the week that most of the other working groups will also be meeting. After that, we'll have the final working group meeting on the 19th of December. Which will be the last working group meeting before the final report is provided to the Connecticut legislature in January. There's also a good opportunity to take a look at when other working groups are meeting, and if anyone would like to join those other working groups, feel free to reach out to myself to get on the mailing list for those upcoming meeting events. All right, now getting to the main events, we wanted to take time in this particular meeting to provide some kind of foundational background information on some of the key components of hydrogen infrastructure or hydrogen systems. So hydrogen infrastructure is not something that's part of most people's daily lives or experience. There's a number of different considerations for things like pipelines or hydrogen storage that are not necessarily equivalent to the considerations for things like natural gas, which most people are more familiar with. So the thought here is to go into some more detail on both hydrogen pipelines and hydrogen storage, two of the key components, give some information on cost and regulations and other concerns related to that infrastructure, so that as we move forward with the development of a system plan for Connecticut, we'll have context on where and why these types of infrastructure are needed, specifically why it's needed, so that as we determine where it's needed, everyone will be moving along at the same pace. So general background on hydrogen pipelines. Hydrogen pipelines are typically composed of steel, including stainless steel and carbon steel alloys. However, these are specially designed pipelines to avoid having hydrogen leakage. Hydrogen being a much smaller molecule than natural gas can leak much more easily, and also requires special materials to avoid having the pipes become embrittled by the chemical characteristics of hydrogen running through it. This includes having a thicker pipeline walls with larger diameters to make sure that these walls can effectively transport hydrogen over long distances. Now, currently, there's not a significant amount of hydrogen pipelines installed in the US compared to existing natural gas infrastructure. However, there is some sizable installations, specifically in the Gulf Coast, where hydrogen is an input for refinery operations. And so there was a need to be able to move hydrogen in this area around quickly and efficiently at scale. You can see a map at the bottom here of some hydrogen pipelines developed and utilized by Air Products, one of the primary providers of hydrogen in the region and in the country as a whole. So why do we need hydrogen pipelines? Under stable demand conditions, as in situations in which you know that there will be a recurring demand for hydrogen in a particular area, that the demand won't fluctuate significantly over days or months or years, pipelines are by far the most economic form of hydrogen delivery compared to other options. There's other options primarily being liquefaction, transportation via trucks. Analysis elsewhere indicates that pipeline delivery is the lowest cost option when market demands exceed 150 metric tons per day. And so that's a good benchmark to understand as we look at and continue to examine the potential demand for hydrogen in Connecticut as a decarbonization strategy. A good rule of thumb to be aware of for the development of infrastructure to support that hydrogen-based decarbonization. Now, although hydrogen pipelines can be cost-effective means of transporting hydrogen at scale, initial capital costs of development are still high, in excess of $1 million per mile if you include the rights of way costs. Although these costs can be reduced if you're able to utilize the rights of way of existing natural gas pipelines. So that is to demonstrate both, the types of costs we're looking at, and also understanding that these are significant infrastructure investments that are require a substantial amount of capital, and so there really is advantage to developing economies of scale with hydrogen. Otherwise, investments of this magnitude simply don't make economic sense. Now, in the future, it's possible that these capital costs be lowered as new materials such as fiber reinforced polymers are developed that can potentially transport hydrogen via pipeline more cheaply than conventional materials. Now, like any other form of pipeline, hydrogen pipelines require permitting and rights of way. There are environmental risks and risks to public safety connected to any type of infrastructure development, especially with gaseous fuels like hydrogen. And so safety permits and environmental impact assessments are required for any hydrogen pipeline project to ensure that surrounding communities and ecosystems are not adversely affected. Again, building along existing rights of way for natural gas pipelines can help to ensure that help streamline this permitting process and make sure that hydrogen pipelines are being deployed or installed in locations where they are will be the least disruptive to surrounding communities. Currently, the Pipeline and Hazardous Materials Safety Administration is responsible for the safety of hydrogen pipelines, like the ones that you identified, or that we identified exist in the Gulf of Mexico. So there are already established agencies and procedures for permitting and constructing these pipelines. And so we're not starting from scratch in this particular area. However, there are new questions around the regulation of hydrogen pipelines, particularly between states. When hydrogen is transported alone as a single fuel, it's covered by the Hepburn Act, which has kind of two sort of iterations or standards related to hydrogen, or related to pipelines carrying gaseous fuels in general. So pipelines carrying petrochemicals with current or potential future energy uses are regulated by FERC and the Interstate Commerce Act. Whereas pipelines carrying materials for energy purposes that do not compete with energy petrochemicals or whose transport costs do not impact energy markets are regulated by the STB and the Interstate Commerce Commission Termination Act. It's a lot of jargon, but the upshot is that up until now, hydrogen has generally been considered subject to STB regulation, but as it becomes a fuel that is used in different energy applications and therefore impacts energy markets, its regulation across states will have to fall under the jurisdiction of either the FERC or the Interstate, sorry, I think it's Interstate Commerce Agency, or sorry, the Interstate Commerce Act. And so there's still uncertainty at the federal level in terms of which agency will ultimately have jurisdiction over interstate hydrogen pipelines. This is something that's still being worked out. And so, we are not able to speak any more differently than either of you are in terms of which will ultimately have jurisdiction over hydrogen, but the decision will have some impact on how easily or how easily hydrogen pipelines can be developed across state lines. For natural gas pipelines with hydrogen blended into it, these are a bit simpler. They're subject to the Natural Gas Act and are therefore within FERC's jurisdiction. Now, another major concern for hydrogen that has been receiving more attention in recent years is fugitive emissions from hydrogen. Fugitive emissions from natural gas pipelines have already been identified and studied extensively as a contributor to climate change. Methane has an extremely high global warming potential, higher than CO2, and so methane leaks across the gas supply chain can contribute significantly to that sector's greenhouse gas emissions. However, recent research has indicated that leaked hydrogen may also contribute more to global warming than previously estimated. Some research suggesting that hydrogen leaked in the atmosphere acts as an indirect greenhouse gas, reacting with pollutants like methane to extend their lifetime in the atmosphere. So although hydrogen itself does not act as a greenhouse gas and block heat from escaping the Earth's atmosphere, it can, through atmospheric chemistry, lead to extended life times for other greenhouse gases. And as a result, it's important to minimize fugitive hydrogen leaks from pipelines as they're developed. I'll also point out this is an active area of study. Since there's not a lot of data at the moment on hydrogen leakage from operational studies, a lot of the analysis is coming from theoretical assessments and simulation, as well as extrapolation from smaller models to larger scale potential emissions impacts. Now, even as this issue is and should be studied in more detail, it is also important to level set about the impact that hydrogen leakage has on the atmosphere compared to natural gas, which is the fuel source that hydrogen is often used to replace. Obviously, natural gas has significant emissions from when it is combusted, which you can see on the right side of that table at the bottom. Whereas hydrogen itself, when it's combusted, does not release any greenhouse gases. And so there's one advantage there. In addition to the difference in emissions from combustion, natural gas also has larger CO2 emissions from estimated CO2 emissions from pipeline leakage than even the non-regulated average of hydrogen, considering the atmospheric properties of both molecules. However, maybe the key takeaway from this table here is that a key element of a safe and climate-friendly hydrogen economy is to ensure that leakage is reduced to a minimum. And so if you have a strong leakage regulation in place, you can significantly reduce the impact of hydrogen leakage on the atmosphere from a greenhouse gas standpoint, which indicates that going forward, as hydrogen pipelines are considered, that from the very beginning, the issue of fugitive hydrogen emissions is kept in mind with regulations and material investments to ensure that leakage is kept at the minimum amounts that it can be held at. Some additional hydrogen leakage best practices identified by the Environmental Defense Fund include continuing to research the impact of hydrogen's indirect radiative effects on temperatures and incorporating them into chemistry climate models. So updating our models to make sure they can factor in the complex interactions that are happening at the atmospheric levels. This includes employing climate metrics and models that effectively reflect the role that hydrogen could play in meeting net zero goals in the desired time frame. The impact of hydrogen on greenhouse gas emissions, similar to methane, changes depending on what time frame you're looking at, whether it's 10 or 20 or 100 years. And so choosing a time frame that reflects that is also important to accurately assess its impact. On the operational side, it's important to improve quantification of hydrogen leakage rates using technologies that can be used in the field to measure hydrogen emissions in real time and at lower detection thresholds than are currently the standard practice. In addition, when making decisions about where and how to effectively deploy hydrogen, the likelihood of hydrogen leakage is something that should be considered so that opportunities to reduce the chance of leakage, so for example, by co-loading production and end-use applications of hydrogen, so that no or relatively short pipelines are required, could be sound decision-making from a climate perspective. Finally, continuing work to identify leakage mitigation measures and best practices should be done now before hydrogen infrastructure is built out at scale. Before jumping into hydrogen storage, I wanted to pause here and see if there are any questions on the subject of hydrogen pipelines.
Hey, Colin, it's Sam Danowski. I raised my hand. May I ask a question?
Of course, yeah, sorry.
Can you talked about the cost estimate per mile. Can you tell us where the source of that information is from?
Not off the top of my head. I can send it to you afterwards, though.
I appreciate that. Yeah, just looking at like recent study in New York on the replacement of gas pipelines. It's 1.3 million per mile in less populated areas, but in population centers it can be as high as 8.7 million a mile. So I want to get a handle on what the true cost is.
That's a really good call out, and something that's worth emphasizing, that the cost of building pipelines changes significantly depending on where you are actually constructing the pipelines. Even constructing water pipelines, based on some work we did in Southern California for hydrogen development, the cost of a water pipeline can be, orders of magnitude higher building through like urban LA versus the surrounding area. And so, an average value like what was presented earlier in this presentation should be taken as a general general guidance versus anytime that a pipeline is actually constructed, you have to take into account the local factors and specific costs of permitting and rights of way. Thanks for that call, Tim.
I had a question too, Colin. This is Sarah with the Green Bank. In the policy working group, we've been talking a lot about workforce development recently. And I know that you mentioned that there's some important differences between natural gas and hydrogen pipelines, but I'm curious if it's a similar skill set to install them, or if it's different material, and people would need to be retrained in order to lay these kind of pipelines.
My understanding is the workforce needs are largely the same for installation. Ultimately, you're digging a hole and laying pipe in it. It might be a different type of pipe, maybe built out of something different, and so maybe the manufacturing of that pipe may have some variations. But in terms of construction, I would say it would be almost a one-for-one skill set transfer.
Thanks.
Of course.
Hey, Colin, I don't know if you can see, but there's no more questions. We should be good to go.
Perfect. Thanks. I'll move on then. All right. So now getting into hydrogen storage, which I personally think is one of the most fascinating components of hydrogen economy. We'll start with some general background. So hydrogen in many places is stored in geologic containers, specifically salt caverns, which can be drilled within salt domes or created embedded salt deposits. Salt caverns are one of the best options for underground hydrogen storage because they have very low permeability and can handle high pressures. Remember, hydrogen is a lighter gas, and so it's easier for hydrogen to escape from man-made infrastructure. That's why pipelines need to be built, especially to move it effectively. It also means that building, above ground storage can be expensive for hydrogen. So in order to, when developing a cost-effective hydrogen infrastructural ecosystem, one of the key factors that will allow you to drive down costs is if you're able to access underground storage such as that, which is available in salt caverns. The United States has a long history of using salt caverns for hydrogen storage, dating back to the 1980s. There's 3 different hydrogen storage salt cavern projects, varying capacities, operating in Texas, that area where that has been the center of most hydrogen infrastructure development up till now. In addition, there's an ongoing project in Delta, Utah, to develop a salt cavern to provide seasonal hydrogen storage. So unlike in Texas, where the storage is really used to support refinery operations, this project in Utah is specifically focused on storing hydrogen produced from renewable energy, so that when renewable energy production is lower in the shoulder months in the winter, you have a clean source of fuel that can be used to power the grid through electricity production. Another reason why salt caverns are particularly good choices for hydrogen storage is the relative ease of injection and withdrawal from salt caverns compared to other geologic storage options. And we'll get into more detail about what those other storage options are in a minute. But first, I think it would be helpful to look a bit more closely at where some of this geologic storage exists, specifically that for salt caverns. So you can see on the map on the right, formations where there's potential for salt caverns to be used to store hydrogen. Large concentration in the Gulf Coast, where the 3 current salt caverns exist. Also in places in the Western US. And closer to home on the East Coast, there's salt cavern formations nearby Connecticut, not actually in Connecticut, but in New York and Pennsylvania. There's perhaps some opportunity to access cheap, cost-effective geologic storage for hydrogen. So looking at the cost profile for hydrogen storage, the levelized cost of hydrogen storage in underground salt caverns can be around 21 cents per kilogram of hydrogen, based on hydrogen production of 50 tons per day, and assuming you're looking at 10 days of hydrogen storage. 75% of that cost is attributed to CapEx of actually developing the storage project. After you develop the storage system, OpEx costs are a relatively minor part of the overall cost structure. And so once again, this is a infrastructure investment that has a high upfront cost, but ultimately can lower the cost of delivering and using hydrogen, assuming that you are able, using that hydrogen at a scale large enough to justify the initial investment. Looking at some other storage options for hydrogen, specifically underground storage, there are a number of different options being investigated now that hydrogen is becoming a greater focus for many that are looking to it to advance their decarbonization goals. Aquifers are one option. These are subsurface layers of permeable rock filled with fresh or saline water, which can operate similarly to salt caverns, with the caveat that they require large volumes of cushion gas to operate effectively, which reduces the capacity available for storing the actual hydrogen gas that you want to keep contained. It's also not an option that's been commercially proven, as no hydrogen storage has been successfully achieved using aquifers at this time. A third option that's quite interesting connection between sort of old and new forms of energy use is the opportunity to store hydrogen in depleted oil and gas reservoirs. Obviously, there are a number of depleted oil and gas wells throughout the US, given the history of developing that particular resource in this country. So this simply opens up the locations that are available for hydrogen storage. However, these depleted reservoirs come with some additional challenges, including potential chemical reactions between H2 and residual oil or gas, as well as a higher risk of leakage. And so this is also an option that's not been commercially proven yet at this point. So that's the end of the sort of hydrogen infrastructure overview we prepared. We now have about 20 minutes left for discussion and questions. So I'll, I can see the screen now, and so if you would like to ask a question or have any comments or follow-up suggestions, other types of information you'd like to learn about, or other areas you'd like to do a deeper dive into, feel free to raise your hand and I'll call on you to unmute. Adolfo.
Hey, Colin, thank you so much for the presentation. Very interesting. One of the things that we've wondered is should we, and I think we should, look into infrastructure at the electrical level, right? Because we're talking green hydrogen in this, at this point. I know that we are looking into all kinds, but particularly for green hydrogen or that hydrogen, obtained through electrolysis, depending on how much we want to ramp up the production, we might need to increase investment probably in the electrical infrastructure, right? Have you guys looked into that, or what's the plan to look into that? Thank you.
That's definitely, thanks Adolfo. That's definitely in scope for this working group. And we will be investigating basically anything that any sort of infrastructure that's required to move hydrogen around or move the electricity to produce hydrogen around is something that we'll investigate as part of this working group. We didn't cover it in this particular presentation because electrical transmission infrastructure is a bit less unfamiliar to most people, especially, I assume, people on this call who work in this industry. And so didn't want to bore anyone with a sort of electrical infrastructure 101 that I'm sure many of you already had at some points, but definitely something that's in scope. Thank you for calling that out, Adolfo. Andrea?
Hi, this is Andrea. Adolfo, that was a great question, but I think you'd probably look at it the other way around, that the production of hydrogen actually has the ability to store the intermittent renewables. So it actually makes it so that you need less electrical infrastructure. Does that make sense? So you don't want to ramp up your electrical capacity just to make hydrogen. You want to produce hydrogen with your excess electricity that when your supply is exceeding your demand. So I support the suggestion that it be studied, but I guess I'm trying to change the scope a little bit to make it a little bit more appropriate.
I see that Adolfo has his hand up again. I assume that's not a legacy hand, so feel free to speak up with your comment.
Yeah, thank you, Andrea. I agree with you up to an extent to that, statement. I mean, it all depends on what are we going to use the hydrogen for, right? So I've been sitting on one of the conversations for end uses of hydrogen, and I mean, I understand that you're talking mostly about using curtailed energy to produce hydrogen, and it's not curtailed anymore, and then we get that hydrogen for whenever we need it, right? But there's a lot of applications that need to have hydrogen at a particular point, being production for mobility applications, or if we want to produce next to one particular customer that already is using gray hydrogen, for example, we want to make that switch, right? And I think we should look into both. For some of the applications, we need to maybe increase or improve the electrical grid, and for others, and I'm with you, that hydrogen is basically a great way to use that otherwise curtailed power.
Thanks, Adolfo. That's a good point.
Thank you.
Yeah, just to follow up on that, there are a number of different configurations of electrical and pipeline infrastructure that you can use to develop a functioning hydrogen ecosystem. You can produce renewable energy and send the energy to electrolyzers to produce next to end users. You can site those electrolyzers next to renewable energy production. And then transport the hydrogen over long distances by pipeline. Or as Andrew pointed out, if you're using curtailed renewable energy to produce hydrogen, or energy that would have been curtailed to produce hydrogen, then you're really leaning on the electrical transmission infrastructure that exists to move that hydrogen or move that electricity to the areas it needs to be for hydrogen production. All of which is something that we'll look at and consider as part of this working group. Sam, I see your hand up.
Yeah, thank you. One thing, I know this is the infrastructure working group, but you did kind of point out that co-location is a very desirable way to approach this. And I think it would be helpful to dig into that a little more and understand it. And particularly, I know as our groups work separately, at some point we're going to come together, and the most desirable end uses for this and what co-location would look like, I think, is extremely important. I know, like, we're nowhere near having excess renewable energy, so we have a long way to go. And as far as a decarbonization strategy, like directly using renewable energy to clean up the biggest emitters, which are transportation and buildings and our electricity generation, seems like the most desirable path there. So these really hard to electrify end uses, understanding what co-location means here in Connecticut vis-a-vis where our production is would be really helpful.
Absolutely. That's a great, Aaron.
If I could chime in here, I think there's some folks on this call who are so familiar with hydrogen that we, I think, sometimes skip ahead a little bit. But just something I want to make sure that folks are familiar with and why we're talking about the concept of co-location is right now, the majority of hydrogen is delivered via trucking. Right. And so when Colin's talking about hydrogen transport infrastructure, we're talking about scaled hydrogen infrastructure that allows transport of very large volumes, either via pipelines or via the electrical system, so that we don't have to be both spending the money on trucking, which is a fairly significant contributor to overall delivered costs, as well as we don't need to be running diesel trucks in order to be getting our clean hydrogen to where it needs to go. And so, Samantha, when you bring up the question of, hey, co-location, what is it? Why is it important? A big part of the very concept of co-location is if we can put the hydrogen production near to the point of offtake, it closes a lot of the gaps in that transport infrastructure. And so to the extent that that's able to facilitate offtake, reduce the final price points that customers see and enable them to adopt hydrogen, that's really a big part of the overall process that we're thinking about as we think about helping to enable and grow a hydrogen ecosystem. So I just want to make sure that we weren't skipping past that point, because I think that's just some really important foundation laying for folks to understand.
Thanks, Erin. So I'm not sure if you were here at the last infrastructure working group for forgive me for not remembering, but we did do some geographic analysis looking at potential locations for hydrogen production from either solar or wind, and potential areas of high hydrogen use within Connecticut. I don't have those maps in this presentation, unfortunately, but hopefully you had a chance to see them.
Yeah, I thought that was very helpful as well, but I don't think we've gotten to the point of like, what's the best use here and what's the best production? I think we're just kind of laying out every possibility and like at some point honing in to prioritize and really have the be able to make recommendations that make the most sense environmentally, cost-wise. I think it's kind of where my head is going as I pick up the pieces and try and thread them together.
Well, sounds like your head is very ready for the uses and sources working group tomorrow, where we'll be addressing a lot of those questions more directly. So happy to hear that.
So Colin, maybe just in the context of some of the questions that we're hearing from folks, I heard from Adolfo and Andrea some of this like, hey, how does electric system infrastructure fit into the overall kind of transport and storage system, and how do we think about the role and potential need for investing in electric infrastructure? I think Samantha's flagging some questions about like, hey, I'm starting to see a lot of the pieces, the individual pieces that we're thinking about, but I'm really trying to understand how all of those come together into a series of recommendations. Maybe if there's no other questions from the audience, and I definitely don't want to get in the way if there are questions, but maybe do you want to spend a couple of minutes just talking about how you're expecting kind of infrastructure uses and sources to be bringing some of these concepts together and potentially synthesizing this information for folks?
Definitely. So, as Samantha mentioned, there is an ongoing effort in the uses and primarily the uses working group to identify potential or highest kind of priority use cases for hydrogen, which will help us kind of help guide us for our analysis in this working group. Once we have identified where hydrogen will be used in the economy, we can identify better where it will be used geographically within the state of Connecticut. And so those maps that you saw at the last working group meeting can be kind of focused in on end uses that where as they're tiered based on relative importance for hydrogen use or relative value for hydrogen use. From there, we can kind of identify the production potential for hydrogen from existing, renewable energy resources in or around Connecticut, including offshore wind, and that'll help us determine, in addition to where hydrogen can be produced, also how much hydrogen can be produced, which will help us focus in our demand analysis because we'll have a better understanding of, kind of how much hydrogen we have to play with, and that'll allow us to make sure that we use this resource in the directed to the highest value use cases. So once we have the areas of hydrogen demand, the amount of hydrogen we'll be producing, are able to produce, and then the areas where it's most valuable to get that hydrogen to, we can start looking at, what are the potential infrastructure solutions for transporting hydrogen from, point A to point B, and what could be the added costs of that transportation infrastructure, whether it be, pipelines, the scale of demand and supply is large enough, whether it be trucking solutions, how to kind of efficiently manage those costs and other impacts, and to what extent we would need to access things like storage or other sorts of, ancillary hydrogen technologies or hydrogen infrastructure installations, such as liquefaction, compressor stations, things like that. Hopefully that sitting from where you are, Aaron, did that seem like it covered everything, or are there any areas that you think would be good to go into more detail about?
No, I think that's helpful. And I mean, I think the other thing is what I'm hearing you say is you're essentially running an IRP process for hydrogen right now across a couple of different work groups where hydrogen uses is essentially our demand assessment and our demand forecasts, right? We'll be picking up supply in sources, and then the infrastructure work group will be primarily focused on hydrogen transport. How do we get hydrogen from where it's being produced to where it needs to be, and whether that's more appropriate to be happening via an electric transmission system, via a pipeline transport system, and also how we make sure that there's access to scaled storage to help with some of the seasonality of production. Is that fair?
That sounds fair to me, though in deference to people who actually run IRPs, I should say that, we'll likely not get into as much detail as, typical IRP process, but the concept is the same.
Okay. Hopefully that helps some folks who are thinking about like, hey, I got a bunch of information today. What do I do with that? Where does it go? How's this going to come together? But please, folks, like chime in. We're trying to help everyone sort of get some of these pieces of information, and I know it's helpful to sort of understand how these different pieces will sort of come together. So please do let us know if there's any other questions on that front.
And to follow up on what Aaron said, this is a good segue into next steps. The kind of analysis that sort of demand and supply portions of the analysis that Aaron talked about will be worked out over the coming weeks. So tomorrow at the Uses and Sources Joint Working Group meeting, we'll be reviewing the evaluation framework for different hydrogen end uses. Ideally, we'll have a very strong idea of which end uses are highest value by the end of this week. Following that, we'll get into the nitty-gritty of assessing the demand from different end uses, using the evaluation criteria to develop scenarios of potential hydrogen demand, low supply scenarios, mid supply scenarios, high supply scenarios, which will dovetail with the analysis from the Sources Working Group, looking at how much hydrogen we could produce regionally or in Connecticut specifically. Connecting those two pieces, we'll get an idea of where hydrogen will be produced, where it will need to be used, and therefore where it will be transported. I'd say we'll have that analysis will be ongoing over the coming months, and we'll have final results ready in the December working groups with updates along the way.
Hi, this is Andrea from Toyota. I'm sorry if I'm stepping back from the framework and if this is a ridiculous question, but at what point will you confirm any of these conclusions with actual end users that volunteer to use the product, or actual industry that builds this kind of infrastructure to confirm these conclusions that you seem to have come to from like a very academic study?
Yeah, that's a really
Like
good
where's
question.
the pull system, I guess?
Mhm. So that's being looked at in the demand analysis. Over the next few months while we're assessing demand, we'll definitely be reaching out to stakeholders in the industry to get a better sense of, how much hydrogen could they conceivably use or need to use in this region? What ways would they be using it? And using that to validate some of the, like you said, more academic studies and research that has guided the approach thus far.
Okay, and those end users understand why hydrogen might work for them versus their other options. Because it's not necessarily just cost, and it's not necessarily just carbon. In fact, a lot of times carbon is one of their last considerations, and cost is their first, and regulation is their second, or any of the other options. But at what point in the study are you finding people that understand that hydrogen is their best option among the ones that are available to them, and they want to go forward with this scenario?
Maybe I can chime in here, Andrea. First of all, as a representative of an industry that is using or contemplating using hydrogen, we would love to talk to you and get your thoughts on this. And we're certainly happy to get your feedback on whether or not what we've put together is sort of aligning with your real world experience of this industry and how it's maturing. I think there's definitely, as we're participating in some of these hubs, there's definitely some tensions between the concept of individual actors who say, hey, I'm interested and ready to adopt hydrogen. I have, started thinking about the process that would be required to change out my infrastructure, and I'm totally ready to go, versus questions on, hey, as a society that is trying to decarbonize our energy systems, what is the best and most efficient use of hydrogen, right? And those are very different
Sure.
questions, right? That we're trying to answer. And part of the really interesting piece with hubs is trying to get to somewhere in the middle, right? Where we have some people who say, yep, I want to be off taking hydrogen. I want to be participating in projects that are trying to kick off relatively soon. And also thinking about how we're using those initial projects as a launch point for some of this broader long-term strategic, where are we trying to go with our energy supply as a society? And so I think a lot of what you've seen from Colin and these work groups so far is that long-term, hey, where are we trying to get to in the end? How do we think we want to be using hydrogen as we look at 2040, 2050? And I think the point you're raising is like, okay, but like I could be building projects now. We could be thinking about projects now. How do we make sure that the work that we're doing is helping to support and inform those projects that are ready to go now, so that we're not losing out on these opportunities?
Yeah, well, I see the value of these studies, but I'm always concerned about when you collect this kind of data and you crunch these kind of numbers, it's possible to overlook some kind of demand scenario. So you write off something on paper. We decided that this option isn't good. We decided that this scenario isn't going to work for whatever reason on paper, but that might be premature to kind of write off that option.
Yeah, no, absolutely. And we've been part of some, hubs related activities where we're starting with calling up off-takers and saying, hey, refineries, which of you is interested to switch from gray hydrogen to green hydrogen? Who's ready to be putting in hydrogen fuel cells? That orientation. And I think, definitely felt like there was some need to be starting here, at least by aligning to some of these broader imperatives. But I think you're raising a really useful point, an important point that we need to be thinking about what comes first, and are those broader imperatives and the policy and regulation that they imply lining up with potentially early adopters, industry interest, and those kinds of questions. So we definitely.
Oh, sorry.
I was just going to say, we do want to hear from folks if they have opinions on that, if they're talking to folks who have opinions on that. I mean, that is a point of these work groups, and we're happy to have those conversations in work groups or offline if there's pieces that folks feel like we really need to be incorporating into this discussion.
Yeah, I was just going to note, Andrea, they're one of the purposes of these working groups, as Aaron stated, is to get feedback from people who are participating in these working groups, which are made up from stakeholders from all across the industry spectrum. And so I've had a number of meetings already with different stakeholders or participants in the uses working group to get their feedback on the initial sort of evaluation framework we developed. And so if this is an area that you're interested in providing feedback in, I'd highly recommend, joining the uses working group tomorrow, or in otherwise getting involved in, that feedback process, because we have developed a pretty extensive feedback process to collect those thoughts to make sure that we're not, kind of preaching from an ivory tower.
Okay, that's great to know. I've only been in a handful of these meetings, and it's very important, but it seemed mostly like a presentation, and I wasn't aware of the feedback. That's fantastic. And as much as we have a lot of experience with things that have worked and not worked in the past, the truth is that we're a supplier. So at the end of the day, we are just a point in the end process. And so we've seen it a lot of times where there's this kind of build it and they will come mentality. And then we try to build it and then people might not come because of whatever reason. So I'm very glad to hear, and I'm probably going to be in the meeting tomorrow as well. So I'm very glad to hear that you're talking with the end use stakeholders as well.
Excellent. Thank you. Well, I see we're over time. So appreciate everyone for joining and for your comments and feedback. And I'm looking forward to seeing you all next in November.
Thank you. Bye.
Talk to you later.
Thank you.
Thanks, everybody.
Thanks,
Take care.
folks.